last section. So in this last section, we're working with the two special right triangles, the 45-45 and the 30-60 right triangles. So remember, there's a pattern to these special triangles. There's a relationship that's always true for triangles with those specific angles, 45-45 and 30-60. So for the 45-45 angle, which is what we've got here in number 17, if that angle is 45 degrees, this one's going to be 45 degrees as well. So in these kind of special right triangles, here's what's always true. Those two sides across from the 45-degree angles, those are always going to be the same length. They're going to be congruent. The hypotenuse is always going to be whatever that length is times square root of 2. So I've already kind of drawn the general relationship for the 45-45 triangle right beside this one to kind of help us match, so to speak. So in this triangle here, number 17, we're given that this side is 8, but it's a 45-45 triangle, so these two sides are the same. So this side is 8 as well. Well, if these two are 8, the hypotenuse, it's got to be 8 times square root of 2. So 8 square root of 2. Those are the other two missing side lengths there. So matching it to the pattern here, so we've got 8, and then 8 square root of 2. Alright, number 18 is also a 45-45 degree triangle, but this time we're given the hypotenuse in this one. So again, I've drawn the 45-45 triangle with the relationship right beside this one, so I can kind of match easier. So let's start with what we know. We know the hypotenuse is 10 square root of 2. So if the hypotenuse is 10 square root of 2, remember that hypotenuse is supposed to be square root of 2 times the length of the two legs. So if my hypotenuse is already written like 10 times square root of 2, that means both of these sides would have to be 10. Because remember the rule. Hypotenuse is this length times square root of 2. So if the hypotenuse is 10 times square root of 2, those two sides have to be 10. There's no way around it. So those two sides are 10. Alright, let's do 30-60 triangles now. So 19, we've got a 30-60 right triangle. So I do have the relationship written right beside it. So 30-60 triangle, relationship's a little bit more complicated. So the side across from the 30-degree angle, that's what we're given here. We're given that is 2. So if that is 2, this side across from the right angle has to be twice that. So if this side is 2, this side is 2 times 2. So it is 4. And for the other side, the side across from the 60-degree angle, so let's see what I'm supposed to do there. So the side across from the 60-degree angle is supposed to be whatever the length of the short leg is times square root of 3. So that's going to be 2 square root of 3. So here I'm given the short leg, and the hypotenuse is twice that, so 4. The other leg, the one across from the 60-degree angle, is square root of 3 times the short leg, so 2 square root of 3. Alright, last one, number 20. So again, it's a 30-60 triangle. I've got the relationship written right here. So let's see what we have to work with. So we're given the hypotenuse. So I have to go from the hypotenuse to these other sides somehow. So the hypotenuse is 6. Well, according to the relationship, that hypotenuse is supposed to be twice the length of that short leg, the leg across from the 30-degree angle. So if 6 is twice as long as y, that makes y have to be 3. Because 2 times 3 is 6. Well, if the short leg, the leg across from 30 degrees, is 3, then the other leg, it has to be that times square root of 3. So it's got to be 3 times square root of 3.